Hello everyone. So this is very interesting question, a very logical one, and of course a bit on a higher difficulty side if seen for first time. And if you're doing in a mock, then of course most probably you would be skipping it. Okay. So anyway, let's see how to solve this question. The question is saying Mr. Goldfinger had a safe with L locks. Now we don't know the number of locks. It's L, a variable. The safe could be opened if all the L keys corresponding to the L locks were available. As he was planning to go abroad for a short while, he employed a team of guards to look after his safe. He also made D duplicates of each of these L keys. So each L keys is having D duplicates, means we don't know how the value of D, it's also a variable, and kept the original set of L keys with himself. For each lock he gave the D duplicate keys to different guards such that no guard got more than one key for that lock. Okay, so the guard is not getting uh, same keys again, means for the same lock he is not getting more than one keys. Okay, he is getting whatever key he is getting is for different locks. That's all it means. In this manner, he distributed all the duplicate keys of all the locks among his guards so that any three guards together could open the safe. Now, this is the most important line. Any three guards together could open the safe, but no two of them together could open it. Alright, so this is the most important line. This is the very important instruction, and using this only you have to solve the complete set. There is not much data here. All the things are given in variable L logs, D duplicates. We don't even know the number of guards, nothing we know, but we only know this data that three guards cannot open the lock, three guards, any three guards can open the lock, and two guards cannot open it. Further, the number of keys given to each guard was same. Okay, so each guard was having the same number of keys. It's not any random number of keys. Alright. And then there are few questions. So before going to questions, first try to figure out what is the situation here. Or maybe situation you understood, you can also look at the questions. It is asking if there were five guards, what is the value of D? If there were five guards, what is the value of L? And what is the minimum possible number of keys with each guard? Six guards, then value of D. So it's kind of when they gave number of guards, they are asking D. So you can know at least, even if you don't know the actual value, when one value is given for number of guards, you should be able to find the number of value of D or L or anything. So there should be a relation between them which you should be getting, and after that you can plug in the values and get the answer. So this is quite obvious from the questions. Okay, but anyhow, let's come to the logic part of this set. Well, if we deal in terms of variable, it would be a bit tough to imagine. So for timing, let's play in numbers. Like if there are suppose five locks, 1 2 3 4 5 locks are there. Okay, and just say there were three guards were there: guard number 1, guard number 2, guard number 3. Now we know that two guards together cannot open the lock. So two guards together should not be able to open these five locks. So maybe I can say he is having two keys, he is having two keys, and he is having two keys. Okay, if I name these as lock number 1, 2, 3, 4, 5, then I'm just saying, so if he is having lock number 1 and 2's keys and he is having lock number 3 and 4 keys, still they will together not be able to open all the five locks, right? They would need person 3's help to give them lock number 5's key. Then only they will be together able to open it. So from this, I'm not telling you the exact values. I'm only saying that even two people together should not be able to open the lock. Okay, they would need the third person to open it. They would be missing at least one key. Okay, now here person number 1 had only two keys and he got two keys from 2 and one keys from 3 to open this lock. In other case, how many keys this person 1 could have at in maximum? Well, maximum he could have, one second, if person number 1, person number 2, person 3, maximum he could have key number 1, 2 and 3. Okay, 1 2 3 4 5, maximum he can have key number 1 2 and 3, and he should be getting one of the keys from 2 that suppose he gets key number 4, still he should not be able to open because there are 5 locks, he has only 4 keys, and then he should get one more key from person number 3. Suppose he will get key number 5 from here, then he should be able to open all the 5 locks and thus the safe. Okay, so this is how I satisfied the condition that even after 2 guards they will not be able to open, but with 3 they will be able to open. So from this, only point I want to make is a guard can have maximum how many keys? Total number of locks minus 2, because then he will need 2 more person to give him at least one key to complete this case, so that he will have all. So one guard can have maximum of total number of locks minus 2 keys. Okay, because he is not having more than one keys of the same lock, so he will have all the key he is having will be for different locks. Then he cannot have more than L minus 2 locks, L minus 2 keys. If he is having L minus 1 keys, suppose he is having 1, 2, 3 and 4, then whoever is having 5 with that guard, these two can together open the safe, which shouldn't be the case. No two guards are able to open the safe together with two of them. They need the third person also, so he will have maximum L minus 2 keys. And since every guard is having equal number of keys, at maximum, as of now I'm not saying exact, as of now I'm saying maximum they can have L minus 2 keys. Now we have to figure out exact how many they can have. Now this point was not very important from these questions perspective, but it was important to understand this question. Now the next thing is, suppose there were 5 guards, which is for which the question is also asked. So let's take there were 5 guards, A, B, C, D and E. I named them. Okay. Now even if I take this combination of guards A and B, they should be missing at least this one key, the fifth one, or any of the key, they should be missing this. Okay, let's just say again I am naming them 1, 2, 3, 4, 5. Even if I combine A and B, they are having all the keys 1 to 4, but they will be missing key number 5. Now here it is mentioned in the question specifically that any 3 guards together could open the safe. So with A and B, if I combine C, D, E or anything, any of the guards, if I bring him here in this group A, B and C or any group I make of 3, they should be having all the 5 keys. So if they are having 1 to 4, who will be having 5th key? All the guards will be having 5th key, C, D, E, everyone, because with A, B, any guard if I mix, they should be having the combination of all 5. Now here I took 5 guards. Even if I take 10 guards and A, B, C, D, E, F, G, H, I, J are there, then if A and B are having 1 to 4 number keys and they are missing the 5th one, each one of them will be having 5th number key, so that if we combine them and make a group of 3, they will have all the keys. If they have 2 to 5 keys and they are missing first key, then everyone will be having key number 1. So from here my point is, each key, this key number 1, this key number 2, this key number 3, each key should go to how many guards? I say when I took 5 guards, this key number 5 would go to these 3 and not to these 2, because these 2 were A and B were not having key number 5, then C, D and E everyone else was having. When I took 10 people A to J, A and B, if these 2 were not having this key number 5, then rest all 8 was having. So we can notice that every key is going to G minus 2 guards. If there are 10 guards, 8 guards will be having key number 5. And similarly with the similar logic, I can say key number 4 also 8 guards will be having, 3 also, 2 also, 1 also. Each key is with G minus 2 guards. Any 2 people will miss it, so that those 2 will not be able to open. Okay, so there will be different combinations, of course, like C and D if we are taking together, maybe these 2 will miss key number 4 and every other guard will be having key number 4. So still the case will be the same, total number of guards minus 2. Any 2 guards will miss that particular key. So this we found what this is. This is one key is given to how many guards? So one key is given to G minus 2 guards. This is what we are clear. Let me write it. One key is given to G minus 2 guards. G minus 2 guards. This part is clear. Or how many duplicates were there? One key is given to G minus 2 guard. What is equivalent to? See, 1, 2, 3, 4, 5 was there. So we said if there are 10 guards A to J, A and B, if these two are not having, rest all C to J will have key number 5. If they are having key number 5 means they are all having duplicates because original the owner took and went away with it. So C to J everyone, that is these 8 guards are having duplicates of key number 5, right? So it means that total number of guards minus 2 duplicates are there. So this whatever we have written that one guard is having G minus one key is given to G minus 2 guards, this is equal to nothing but the value of D, that is number of duplicates for each key, is nothing but G minus 2, and this is the way how we got a relation between both of them. So from here itself we can answer for the first question. If there are 5 guards, what is the value of D? D is equal to 5 minus 2, that is 3. And if there are 6 guards, what is the value of D? D is equals to 6 minus 2, that is 4. So if you got this logic, you can straight away get 6 marks here. Alright. Now still some values we need to find out in order to solve the complete set. Now we got the relation between number of guards and duplicates. What are we still missing? About the relation between logs. So let's see again. Again, if I am saying 1, 2, 3, 4 and 5 number logs are there. Let's say there are, suppose not 5 this time I will take, let's say there are 4 guards A, B, C and D. Now I know that combination of 2 guards cannot open the lock. So A, B together cannot open it, AC, AD, then BC, BD and CD. So we have nothing but 4C2, that is 6 combinations of guards, and they cannot open it. Every one of them will miss at least one key, right? And that particular one key everyone else will be having. Like if A and B are missing key number 1, then C and D both will be having that key number 1. Okay. Now one thing you can notice that A and B are they are lacking one key. B and D is also lacking one key. B and C is also lacking one key. C and D also, A and C also, A and D also, all 6. We made 4C equal to 6 combinations, and we know that all 6 combinations are lacking one key. Then what could be the number of locks? Well, each one of them is lacking one key. He is lacking one key. He is lacking one key. He is lacking one key. 1, 2, 3, 4, 5, 6. So I can simply say they would be lacking 6 keys. So there will be 6 locks at least. Now some of you might say that what if this combination and this combination is lacking the same key, that is key number 1, then that way we will be having less than 6 locks. But is that possible? Because you are saying that AB and BC, they are lacking the same key, that is key number 1. In this case, if I combine A, B and C, that will make a group of 3 ABC. If they are both lacking key number 1, then how they will be able to open the lock? That wouldn't be possible, right? So this point that any 3 guards together can open the lock differentiates with this the fact that there will be different keys that each group will be lacking. Each group of 2 will be lacking different keys, because if any 2 group is lacking the same key, then the combination of those 3, or even if I take AB and CD, if they two both are lacking the same keys, that is key number 2 suppose, then it is saying that combining any 3 guards together I can open the lock, all the 5. But here, even after combining all the 4 guards A, B, C and D, I will not be able to open because they all are lacking key number 1. So that shouldn't be possible. Even if I take AB and AC, if they both groups are lacking key number 3, it will not be possible that A, B and C together will open the locks. So from here we are sure that each combination of 2 is lacking one separate key. So the number of locks will be at least equal to the number of combinations of 2. So if there are G guards, we can make GC2 groups of 2, right? GC2 groups we can make. So this L, the number of locks, now I will simply write it. Give me a second. So now I can write that the number of locks and its minimum value is equal to GC2, because this is the at least I am saying. At least GC2 locks are there for sure, because that many keys they would be lacking. So if that many keys are there, means that many locks are there. So L minimum is GC2. Now this answers our second question. That the question is, if there were 5 guards, what is the minimum possible value of L? That will be 5C2. That gives us the answer as 10. Now if there were 5 guards, what is the minimum possible number of keys with each guard? Uh, okay. Well, it is asking minimum possible number of keys. Now see, there are 5 guards, so G is equal to 5. Now since G is equal to 5, what is the value of D, that is duplicates? Number of duplicate keys is nothing but 5 minus 2 is equal to 3. That is the number of duplicate keys for each lock. Each lock is having 3 keys. And what is the number of locks? Number of locks will be at least 5C2 is equal to 10. Now there are at least 10 locks, means number of locks is greater than or equal to 10. And each lock is having 3 keys, means 10 locks will be having 10 into 3, that will be 30 keys. If it is 11 then 33, 12 then 36 and so on. But at least 10 means minimum 10 locks will have minimum of 30 keys. So, and it is asking for minimum possible number of keys only. So the answer for third question is nothing but 30. Or this in general way also I can write, if it is not asking for, if it means that I am just answering all the questions generally. First question, if number of guards was not given, they are saying G also, then the value of D is nothing but G minus 2. Second question is, answer is GC2. Third question's answer would be nothing but GC2, that is the number of locks. One second, give me a second. GC2, that is the number of locks, into number of duplicates, GC2 into D. And fourth question is again D, that is G minus 2. So this is the general value. They can even change the values, or they can even ask in the form of formula direct, giving you the options. You should be able to solve it now according to the logic. You got the logic, right? So of course it was a bit difficult to comprehend in the beginning, but it's not that tough if you understand. Yeah, that's with all the questions. If you understand the logic, it will not be very much tough. But to comprehend, especially in the exam scenarios, it will be difficult. Okay. Anyway, so now I hope this question is clear to you. Okay, if you have any doubt, of course you can ask me in comments. All right.